For us here in week number 3 of remote learning, we need to go ahead and start covering things like our food chains. We need to cover things like food webs. And then we also need to talk a little bit about our threatened, endangered, and extinct species. We know that those words are going to show up not only on the quiz, but on the upcoming assessment as well. When we're looking at an ecosystem, it is very easy to pretty much start everything with the sun. The sun is the main source of energy in an ecosystem, and I have seen that question specifically, what is the main source of energy in an ecosystem, show up very often. So you will probably see something very similar to this when we get to the SchoolNet tests and the assessments that talk about what is the main source of energy. Well, we know that the sun starts it all because that's where the very first energy transfer occurs. The sun sends its energy to the producers, which is going to be the first thing that we talk about when we talk about our food chains, our food webs, and even our food pyramids that we get into. We talk about the sun being the main source of energy for that. So food chains and food pyramids and food webs are all interconnected, and it always starts with the sun being the main source of energy. So if we take a look at this is like a nice, almost like a circle, the way things kind of go in here. It's like a linked chain. Obviously, the sun would be here, and it gives energy to the producer or the grass. So through photosynthesis, the producers are able to make their own energy. That's when we get to our herbivores, and we call this, there's two things. We call it our primary consumer because it's the first person to eat. And sometimes they call it the first consumer. I like first consumer, but I see primary consumer show up very often. That is your herbivores. They are the first thing to eat. They eat the grass. So the primary consumer. Then we're moving along in this, it's linked. It's all connected. So the energy from the grass, some of that energy goes into the grasshopper. Now, the grasshopper has energy stored inside of it, and it gets eaten by a bluebird, which is your second consumer or your secondary consumer. And so when we see this now, we know that the sunlight gave energy to the grass gave energy to the grasshopper, now the grasshopper is giving energy to the bluebird. So the bluebird is flying, he lands on the grass, and he gets eaten by the snake. The snake is the third person to eat in this food chain. And they do call it the third consumer, but they use this word here, tertiary consumer, the tertiary consumer. The way to remember that is it starts with a T, third starts with a T. Your tertiary or third consumer is the third person to eat. So now you got to think of it like this. The sun had given energy to the grass. The grass had grown through photosynthesis. The grasshopper ate the grass. It took in some of that energy. Then it was eaten by the bluebird. So the bluebird took in the energy that was inside of the grasshopper. Now the bluebird has been eaten by the snake. The snake's belly is full. He's laying there. And then you get eaten by your fourth consumer. And unfortunately, fourth consumer has many different names. Fourth consumer, apex predator, quaternary consumer, which we will see in a moment. It is the fourth thing to eat in this particular food chain. Now, eventually, I guess this owl could get sick and fall, and he could get eaten, and they'd have like a fifth consumer that eats it. Or maybe the owl just falls over and dies. And we know that when the owl dies, it's dead and decaying. Decomposers break this owl back down into the nutrients that are stored inside of it, and it releases that back into the soil, which helps the producers then grow, because you can see how the energy would move through this chain of events that would happen. So that's what a food chain kind of looks like. And our definition for food chain is the path of energy in food from one organism to another. The path of energy. Now, if we look at something very simple food chain here, sun gives energy to the grass gives energy to the grasshopper gives energy to the blue jay, and the blue jay gives energy to the owl. You can even have a shorter food chain. Sun gives energy to the grass to the rabbit to the hawk, the end. And so you wouldn't really have a lot of things to necessarily mess with anything in there. Now, the one thing about food chains and food webs that we have to start thinking about this and really start digging deep into it is, What happens when one of these becomes greatly affected? For instance, in this food chain here, what would happen if a large amount of grasshoppers moved into the area? Basically, the grasshopper population grew, or the herbivore population grew. What would happen? Well, you got to think there's more grasshoppers, so they would eat more grass, which means the grass population would go down. It would go down. Now, if there are more grasshoppers, would that make the blue jay population go down? Probably not. If there's more grasshoppers, there might be more blue jays moving into the area, because we know that the ecosystem likes to keep that balance. Having too many grasshoppers, we exceed the carrying capacity, and ecosystems do not like that. So there might be more blue jays move in to eat more grasshoppers to then get the grasshoppers down to the correct number, and then they would all disperse and move back to where they would need to. That really wouldn't have a giant effect on the owl if the grasshopper population grew. Maybe if the blue jay population grew, more owls would move into the area so they could then eat the blue jays. But it would have the least effect on this. But the biggest effect would be on the grass. Too many grasshoppers means more grass is eaten, so that's not a good thing. So a food chain is the path of energy in food from one organism to another. We need to, again, like I said, we need to look at a food chain and determine what would happen if certain things were affected negatively or positively. So in this food chain, what would happen if the bird population increased? Well, number one, you have to know what a bird is. Okay, so we're talking here, we're not saying the owl, we're saying the bird. You got to look at what they're listed as. Okay, don't just be like, oh, it's flying, it's a bird. Not the owl population, the bird. If the bird population went up, well, if there's more birds, they're going to eat more grasshoppers. Therefore, the grasshopper population would decrease. And then if you want to keep following that link all the way down, if there's less grasshoppers, there's going to be more grass. If there's more birds, there could possibly be more snakes and then, therefore, more owls. But the biggest thing, if the birds were to go up, the biggest thing that would have an effect on is, what are they eating? Well, they're eating grasshoppers. So grasshoppers would go down. Conversely, if we change that around and we said, what would happen if the bird population went down? Now there are less birds. Now you've got two effects. That's going to affect the snakes because they have less food. So their population would go down. But if you use less birds, there's going to be more grasshoppers. And more grasshoppers means less grass. It is very tough to work through these food chains. And that is most definitely something we will practice as we move through this week. And we talk about that. But there are a lot of questions that you're going to see that are basically involved. They're going to show you a food chain or a food web and then give you a scenario. What would happen if? And you got to be able to work your way through that food chain. Food webs. Food webs are nothing more than a bunch of food chains that overlap each other. See, we were used to looking at this, plant to caterpillar to bird, and that was no problem. There's one food chain. However, this plant is not only eaten by the caterpillar, but it's eaten by this aphid as well. So now you have overlapping food chains, which gives you your food web. And you can see how if you crisscross all these lines, it no longer looks like a straight chain, it looks like a spider web. And it is very similar to a spider web. Food webs are, the only thing about them is they're a little bit more complex. They have more parts to the puzzle. It's just food chains, it's just a bunch of food chains in one picture. So don't let that confuse you. It's really not super difficult. We could look at this and say, what happens if the fox population goes up? Well, there's going to be less rabbits and less voles because that's what the fox eats. So you would just look at it that way. If the rabbit population happened to go down, that would mean there's more grass. That doesn't mean the voles are going to eat more grass because there's more grass. There's just more grass because the rabbits aren't eating their fair share. And the food web is where you can really start to see that carrying capacity and how well is the ecosystem able to stay in balance. Just as we did, like I said, with food chains, we have to look at what changes would occur if there was ever something positive or negative to happen in a food web. Whoops, let me go back to this. For example, we look at this. What would happen if the rabbit population went down? Okay, so the rabbit population goes down. There's less rabbits. If there are less rabbits, I see two major effects. There's going to be more grass because there's less rabbits eating the grass. And if we have a decrease, which means go down, if we have a decrease in rabbits, that's less food for the hawk. Does the hawk eat anything else? Well, he eats snakes, but that's less food, so there would be less hawks. I think the biggest thing would be there's more grass. If there's less rabbits, more grass. The caterpillars and the grasshoppers aren't going to start eating more just because the rabbits are gone. There's less grass, and because the rabbit population, there's more grass. Did I say less grass? Oh my goodness, Mr. Bullens, get with it. There's more grass if the rabbits go down. More grass because there's more grass growing. There's less rabbits eating. I apologize for making that mistake. And that's easy to do. Like, learn from me. Don't make that mistake when you're doing this. So that's the way you would look at that. Food and energy pyramids. Honestly, they're no different than looking at a food chain. It's just a different way to draw a food chain. Okay? If you look at this, okay, we have the different levels of a pyramid. 1, 2, 3, 4, 5. Well, it's very basic. Look at any ecosystem. And what do you have the most of? Well, you have more plants than anything. That's why they're at the bottom. And then if you think about it, if you move up to the next level, what eats the plants? Well, you have your first level consumers, the herbivores, right? What eats them? Well, this is the first level to eat the secondary consumers, the third level consumers, or the tertiary consumers, the quaternary, or that apex predator that we talked about a little bit earlier. So if we look at this, we have down here, we have our producers. That's at the bottom. There's more plants than anything else in there. If we move up one level, we have our first level consumers, our first thing to eat, our herbivores. The next layer, we have our secondary consumers. Okay, secondary consumers. Now, again, I'm not going to get into are they carnivores or omnivores. It depends on what they eat. But this frog, in this instance, is eating the grasshopper, and that's it. Then it would be a carnivore. But that is don't get it confused. This is the first level, but this is the first person to eat is here. The secondary person to eat is here. Which means if we move up again, this is the third level that eats. We have something called, and here's that word, tertiary consumers. Because here's our first level. Grass is not doing any eating. It is a plant, a producer. It's not doing any eating. We move up one level to the first level to eat is your first level consumers. Move up again to your second level, your secondary consumers, and then up again to your tertiary consumers. If I move to the top and you think 1, 2, 3, 4, the fourth person to eat could be the fourth consumer, could be the apex predator, but there's another word that shows up every now and then, quaternary consumer. Now that has that quad in there. If you happen to ride a quad on the weekends, you're riding a four-wheeler through the woods and through like the farm or something, because quaternary is the fourth level consumer. So you think grass isn't eating, it's a producer. It makes its own food. The first person to eat is here, first level. Second person to eat here, secondary, pretty easy. Third level to eat. Third level consumer is easy. Tertiary starts with a T, so does third. And then you get up to your quaternary. Just remember that if you have a quad of something, that's 4, but your quaternary, your fourth level consumer, your apex predator, is at the top. You can do this matching on your own. And we've talked about limiting factors. Limiting factors are things in an ecosystem that keep populations up or keep populations down. Now, it's easy to think of sun, soil, climate, and water. Of course, that affects how many things grow and move in an ecosystem. But if you happen to be living in the savannah and there's way more lions, well, that's a limiting factor to me. Anything that controls the growth or survival of a population in an area is a limiting factor. We're going to stop there, and we will pick up again later.